Hello, students. Welcome to the final lesson, lesson 6 of our distance learning plan that we have. So in this lesson, we will be finishing up with our Algebra 1 trigonometry unit we're in. So we are focusing in on HH6, which is solving a right triangle. This isn't anything new. You actually have all of the skills from lessons 1 through 5 that we'll be combining today into one lesson. So you're going to be finding angles or side lengths depending on what you're given here. So you're going to have to use inverse trig to find those angle measures, or the easier way is to take it away from 180 if you can solve it that way. So I put on a couple different problems for us to get through. Some are missing two sides and one angle. Some are missing two angles and one side. None of them, I don't think, are missing all three angles or all three sides. Okay? We need at least one side to find the others anyway, so that wouldn't be an option to have all three missing. So let's start with number 1. The first thing I'm going to do is the easiest part, or what I think is the easiest part. See how we already have an angle here and another angle here? It's super easy to find this one without using any trig whatsoever. So I'm going to do 100 and I'm going to do 90 degrees plus 51 degrees, and that's 141 degrees. And then I'm going to do 180, take away 141, okay, because I want to find the missing piece, and that's going to be 39 degrees. So this one right here, measure of angle Q, is 39 degrees. Always try to do that if you can. If you are given two of the angles, just use the idea that a triangle's add up to 180 degrees and solve for the missing angle. And now I just need to find the side lengths. So I'm going to call the first side length X, and I'll call the other side length Y, just to keep it easier with the variables. So with this, I'm going to say I need to use a trig function. So I'm going to use the angle they gave me and say that I'm going to do the adjacent over the hypotenuse. Okay, so wait a minute. Let me change the color so it's correlated. Wait a minute. What do I want to do? Sure, I'll change these. Whoops. I will change the color of this right here, of these, to orange. Okay, so I'm going to do adjacent over hypotenuse. So the cosine of an angle is equal to the adjacent over the hypotenuse. So the cosine of 51 degrees equals x over 9. Okay? Where can I put let me put these up here to get them out of the way. That's going to drive me crazy. Okay. So now the cosine of my angle is adjacent over hypotenuse. Cosine of 51 equals x over 9. So now I'm going to multiply both sides by 9. Let me use multiply both sides by 9. No, I'm going to stick with orange. I'm going to stick with orange the entire time here so that it's connected to what I'm solving for. All right, that's going to go away. I now have 9 times the cosine of 51 degrees, and that's equal to x. So x approximately equals, it's going to be rounded to the nearest tenth. So 9 cosine of 51, 9, don't forget cosine of 51. Make sure your calculator is in degree mode. I've already checked mine. It's in degree mode. So 9 cosine of 51, and that is 5.6638. 5.6638. 5.6638. and we're rounding to the nearest tenth. So that's going to round it up. So x approximately equals 5.6. Oh, sorry, 5.7. Okay. What is x? X is PR. So PR is 5.7 because I used a variable for PR to make it a little bit easier. Okay. Now the last one here is going to be the opposite over the hypotenuse. So I'm going to do this again. So I'm going to do the opposite over the hypotenuse. Everything I'm doing is in terms of the 51-degree angle. So in maroon, I will do this one, okay? So the opposite over the hypotenuse is the sine function. So it's the sine of the angle. So it's sine of 51 degrees equals the opposite side. We'll call that y over the hypotenuse, which is 9. So multiply both sides by 9 to get 9 away from the y. So we get 9 times sine of 51 degrees. And that equals y. So that isolates y by itself. Let me just put a degree measure in there. So now I need to do y approximately equals 9 sine of 51. And I'm going to hit enter. And I get 6.9943. 6.9943. I round it. So y approximately equals 6.9 rounds up to 7.0. You can use 7 or 7.0. Okay? It's a lot of work. So this lesson is going to take a little bit longer than, a little bit longer than the previous ones because we're really answering 3 questions all together at once. All right. So again, I did basic algebra to find my angle measure, and then I went from there to find the rest. And then I did trig for the other 2 to find my side lengths. Okay. All right. The next one here, we're given the same thing. We're given one angle, and we're given an angle. So I'm gonna do let's do 56 plus 90. That's 146 degrees, and then I'm gonna do 180. Take away 146 because I'm taking away the 90 and then I'm taking away the 56. Okay, so that's 34 degrees. So 34 and 56, those add up to 90 while the other one adds up to 90. So this one is 34 degrees. I'm not even going to use it right now. I need to solve for it. Okay. Now, I'm going to use what they gave me, 56, because I can't make a mistake in that case. I'm going to call this one X, and I'm going to call this one Y. All right, so I'm going to do 56. I'm going to do, let's see. Let me use green. Here's my opposite side. It's my opposite. Here's my hypotenuse. And then this one is my adjacent side. So I'm going to have 2 functions. The first one is going to be the sine. Wait a minute. I wanted to keep the colors consistent. That's all right. Let's just keep all of sine. So I'm going to be using sine of my angle, which is opposite over hypotenuse. And then I'm going to be also using the cosine function. Okay, and that one I'll do in maroon. No, I already used maroon, orange. The cosine of my angle equals adjacent over hypotenuse. And I get two things going on. For cosine, I have cosine of 56, and that equals x over, oh, wait a minute. You know what? I can't use, what am I doing here? I can use the sine function, but I can't use the cosine function. I made a mistake. Let me set up the sine function for you and show you why. So the sine of 56 degrees equals the opposite, which is 6, over the hypotenuse, which is y. So I need to use the 6 twice. So in the other case, I'm going to have to say the tangent of 56 degrees. Oh, let me say the tangent of my angle equals opposite over adjacent. Notice that for the cosine function, if I did adjacent over hypotenuse, I have two variables, and it doesn't work with that. I can only have one. So the tangent of 56 degrees equals the opposite 6 over the adjacent x. And now I've limited both of these to being just two. There we go. As being two, the two functions I'm going to use. Okay. Now I'm going to have to solve both of these. So the first one, sine, I'll solve this one first. I'm going to multiply by y and multiply by y. Let me use a different color. I'll use this one. There we go. Multiply by y, multiply by y. And that gets me y times sine of 56 degrees equals 6. And I'm going to divide both sides by the sine of 56 degrees. So this one again, you could have just switched these two if you wanted. I'm going to go crazy. Here we go. Okay. There we go. You could have switched these two because one's in a numerator, one's in a denominator. Or you can multiply both sides by y, and then you'll have to divide this one back out. Okay. Either way, you get y equals 6 over sine of 56 degrees. So y approximately equals 6 divided by sine 56. And we get about 7.2373. 7.2373. 7.2373. Yep. And when we round to the nearest tenth, you get y approximately equals 7.2. Okay. Y approximately equals 7.2. And then the next one, this tangent one, let me move it over, save some room here, get some room back. I'll use this color. Okay. First thing I'm going to do is multiply by x. Again, you can just switch these. You can just switch these two if you want, and you're good to go. You'll have 6 divided by the tangent of 56 down here. But if you like solving it this way, that's fine. So you get x times tangent of 56 degrees equals 6. Divide both sides by tangent of 56. Tangent of 56. And we get x equals 6 divided by tangent of 56 degrees. x approximately equals 6 divided by tangent of 56. Four point oh four seven oh. 4.0470. Rounded to nearest tenth, so go to the 100th place. It rounds it off to 4.0. Okay? What is x? X we made FG, so FG is 4.0. And then Y we made GH, so GH is 7.2. All right. So we have 7.2 for that one. All right. Let's see. Is there more? There is. I did 2 more. I did a lot of examples. I don't think we need that many. Let's do this one, because this one does have an angle measure. Let's see. Hopefully my sound doesn't cut out. It looks like I'm running low on. Power. All right, this one. The first thing we want to do is find DE. And so this one, the easiest way to do that is to do the Pythagorean theorem, because look at, you're just missing one other side. So let's do, and then we can do, then we'll use inverse trig to find C and E. So L squared plus L squared equals H squared. So we're going to do 5 squared plus x squared equals 7 squared. So 25 plus x squared equals 49. Take away 25. X squared equals 24. And then we're just going to find the square root of x squared and the square root of 24. So x approximately equals the square root of 24. Now it's weird that in the trig unit we would be using the Pythagorean theorem, but they are connected. 4.8989, 4.8989. They are connected, and so we're going to want to do exactly as possible, and that's the easiest one to solve for using the Pythagorean theorem. Now nearest tenth, so 4.9, so that's going there. 4.9 we rounded to. Okay, I rounded. I do not want to use the rounded value when I calculate my angle measure. So I want to do anything I possibly can without using that rounded value. So I want to use the numbers 5 and 7. Okay? So for 5, I'm going to do, ready for this? To find C, I'm going to use, I'm going to use the adjacent side over the hypotenuse side. So to find the measure of angle C, I'm going to use the cosine function. Cosine of my angle is adjacent over hypotenuse. So the cosine of angle C is equal to 5 over 7 So I'm going to inverse these, okay? So inverse of c in 5 over 7. So cosine inverse of 5 over 7 equals the measure of angle C. So the measure of angle C is approximately equal to, and I'm going to do that in my calculator, inverse cosine of 5 over 7. So inverse cosine, let's see, inverse cosine, arc cosine of 5 divided by 7 equals 44.415, 44.415, 44.415. It says write your answers as integers around the nearest tenth, so we are rounding this to nearest tenth. So measure of angle C equals 44.4 degrees. Because it doesn't round up, it rounds off. So 44.4. Now using algebra, I could just do 90 minus 44.4 and get this last answer. So let's see, 90 minus 44.4 is equal to 45.6. So this one right here is 45.6. Why is that? Because again, this one is 90. If this one's 44.4, this one has to be 45.6 because they both have to add up to 90 for it to all add up to 180. But if you don't trust that or you want to check your work, that's a great thing to do. We're going to set up, we're going to do, let's do in this case, we wanted to find, we have E over here. We want to know what E is. So we're going to do E is equal to the opposite. Notice how it's opposite now. It's not adjacent because adjacent's what's in blue. It's angle C. This is the opposite and the hypotenuse. It will always be the hypotenuse, but in this case, for angle E, 5 is opposite to it. So I'm going to say that the sine of my angle is equal to opposite over hypotenuse. So the sine of angle E equals 5 over 7. Again, we're using the same fraction. I'm going to switch angle E and 5/7 and do sine inverse of angle E, of 5 over 7 equals, okay, all right, this isn't working well. Let's try that again. Equals the measure of angle E. So the measure of angle E approximately equals sine inverse of, now we should get 45.6 about that. So sine inverse, it's of 5 divided by 7, 45.58, 45.58, and that rounds it up to, what did I say? 45.6, which is what we have. Okay, give me 1 second. Let me try to see what my AirPods are at so that they, okay, I have enough, I think, to get through the lesson. All right. Again, we can, this is just like the one above. This one has decimals, and this one has square roots. So let me do this one with square roots, and I think we'll call it a day because this video's already been going on for quite a long time. You can ask questions though. Remember, you can ask in all of our Google Meets that we do. So let's solve this one. the first thing I want to do is do 90 plus 36 is 126, and then 180 take away 126 equals 54. So what I was doing was I was finding 54 degrees up here. So take away the 90 you know and the 36 you know. So together that's 126. That'll give you 54 degrees. So 36 plus 54 is 90 degrees. So it adds up to 180. Okay? Now the next one we're going to do, we need to find x and y. We are given a hypotenuse, so we're going to have to definitely use sine and cosine. We won't be able to use tangent because remember what happened when I did tangent? You get two variables for tangent if you do tangent, okay? So we don't want to do tangent. We do want to do, whoops. Okay, good, 54. We do want to make sure that we don't use tangent for this problem because we are given a hypotenuse, therefore we're going to use both trig functions that involve a hypotenuse. Those are sine and cosine. So we're going to do sine of my angle equals opposite over hypotenuse. And the tangent of my angle, the cosine of my angle equals the adjacent over the hypotenuse. All right, let's use 36 because that's what they gave me. So for 36, this is going to be the opposite side. This is the adjacent side. And this is the hypotenuse. Let me use different colors. Whoops. Yep, okay. This one is your adjacent and the hypotenuse again. Okay, so for cosine, we're going to do cosine of angle y. Let's see, cosine of angle, it's cosine of 36 degrees, I'm sorry. Cosine of 36 degrees equals the adjacent over the hypotenuse, so y over the square root of 65. And for sine, it's going to be sine of 36 degrees equals x over, we used x as a variable, over the square root of 65. So to solve for these, we're going to multiply both sides. For this one, we'll multiply both sides by square root of 65. And then we'll get square root of 65 times the sine of 36 degrees equals x. So x approximately equals. We'll do that in our calculator in 1 second. But let's do this one as well. So we're going to do times the square root of 65 times the, oh, we're running out of room. Okay, times the square root of 65. So we get the square root of 65 times cosine of 36 degrees equals y. So y approximately equals, and we're going to do both of these in our calculator. Okay? Now, I want to show you how to type it in. We got to be careful. We're going to have to make sure 65 doesn't get connected to sine of 36. So let's be very careful. So we want to do the square root of 65. So I'm going to do the square root of 65, and then I'm going to close parentheses. Make sure you close them, times sine, and what am I at? Sine of 36. Okay, sine of 36. Whoops, 36. See how cautious I was? I made sure I did parentheses around the 65, parentheses around the 36, and put multiplication in between the two because the product of both of those. Okay? And the answer is 4.7388. 4.7388. 4.7388. And we're rounding to the nearest tenth. So x approximately equals 4.7 because it rounds off. So x is 4.7, which is g, about 4.7. It's GH. Okay. And the last one, we're going to type that in, 65 and 36. So the square root of 65, close parentheses, cosine of 36, I believe it was. Let me just check. Yep, so that's in our calculator. We're going to hit enter. Whoops. Make sure it's parentheses around each one. Oh, we can put a times in between if we want. It's actually going to times it for me, but here, let's just be consistent. Cosine of 36, I believe it was, right? Yep. Okay. 6.5225. 6.5225. 6.5225. We're going to go to the 100th place. It is going to round it off. So 6.5 is this one, which is HF, which is 6.5. Okay? I think the lesson is long enough. I don't want to overburden you with practice. You can, if you want to call in and work on this with one of us, that's fine. It's a lot of work. We can look over your work as you're doing it. Yeah, so call in or book appointments, or we might book them for you on Google Meet. All right, good luck with your last lesson.